Thank you very much, and good morning to everybody in North America. Thank you for joining us, and good afternoon for those in Europe and colleagues elsewhere. This is the NVH Roundtable for the Zero Prototype Summit by VI Grade, and I want to extend a warm welcome to all of you. In the interest of time, since we only have about 50 minutes, I'm going to take the liberty to introduce each one of our panelists. And my PowerPoint does not seem to be moving forward. Are you still seeing my first slide?
Yes.
Yeah. Oh, you see the second slide now?
Yes, we see the second slide.
Very good. Very good. Okay, so again, I'd like to give everyone a welcome. My name is Colin Novak. I'll be the moderator for this morning's session. I'm a professor and director of the NVH Sound Quality Research Labs at the University of Windsor. My areas of research are automotive NVH sound quality, as well as the development of psychoacoustic metrics. I'd like to welcome Marco Ballatore from Ferrari. Marco is a vehicle NVH department manager at Maranello. Marco is responsible for concept and physical vehicle development for sound, vibration, and structural dynamic performance for all Ferrari models. And these introductions, by the way, are in alphabetical order. So next we have Dave Bogema from VI Grade. Dave is the director of NVH Solutions at VI Grade. And he sits at the Application Research Center in Canton, Michigan. Dave is responsible for NVH simulation technologies and solutions for VI Grade. We have Chris Cundy, who's a supervisor for powertrain systems and NVH optimization at Ford. He's out of Dearborn, Michigan. Chris is responsible for development of powertrain NVH simulation methods and program support for resolution of powertrain NVH issues. Next, we have Ashley Gillibrand from Jaguar Land Rover. He's from Gayton Engineering Center near Warwick in the United Kingdom and is responsible for development and delivery of NVH driving simulations in support for future products. We have Rabah from HBK, also at the offices in Canton. And Rabah is responsible for the execution and management of NVH project services to help HBK customers improve the NVH performance of their products. Next, we have Len Layton from Blackberry QNX acoustics team out of Burnaby, British Columbia. Len is responsible for supporting QNX acoustics customers, as well as their partners and their prospects. We have Aaron Locke, who is a senior manager for NVH and durability out of Plymouth for Rivian. Aaron leads teams in North America and the UK and is responsible for delivering of NVH attributes and implementing new technologies to robustly speed development. And we have Glenn Pietila from General Motors. He's at the Proving Grounds in Milford, Michigan. Glenn is responsible for sound design and process development for sound enhancement technologies. So what we're going to do is I'm going to ask a question of each one of our panelists. We have about 5 minutes to listen to their thoughts. And if we still have time when they're done, I'm going to open it up to the other panelists to also add any questions or comments that they may have. So I want to start off by first saying that the NVH Simulator is an excellent tool to help meet design targets. I think we all agree that this is a traditional application for the virtual NVH simulation. However, I want to start off our discussion by touching on the less conventional applications for the virtual NVH design tools, such as the driving simulator. So let's start off with Len. I think of QNX as a company that supports customers that are working on innovative designs that may fall under the less conventional category. For example, maybe the integration of the car audio system with in-vehicle communications infrastructure, or perhaps an active sound control system. Len, moving towards a zero prototype philosophy, how do you see virtual simulation software being used to improve the end user experience regarding these kinds of system integrations?
Thanks, Colin. I think that it's really great to be here at this summit. I think the topic is incredibly valuable right now because of many aspects of vehicle development. Of course, have had to change because of the pandemic. And I think simulation is obviously becoming incredibly important. And it's, I think, accelerating a trend that was already happening across the industry towards more use of simulation. And at Blackberry QNX, what we're doing is we're building software that goes into the actual vehicles, into production vehicles. And OEMs now are seeing software as a key way to differentiate their products between their products and their competitors' products. And software is a complex thing. It's as much art as science in some ways. And so developing that software that includes the kind of sound creation technologies that we know that we have today, and getting those integrated into a vehicle in a way in which is valuable to an OEM is really important to Blackberry QNX. And what we're trying to do is build a system that can close the gaps between the design concepts that sound designers have and OEMs have and their brand concepts, and close the gap between those concepts and the production programs. And so with this collaboration that we've established with VI Grade, I think there's a fantastic way to bring a simulator that brings the context of the sound designs that you're going to hear and experience in a real physical vehicle. It brings that context to life with the addition of active sound design technology from Blackberry QNX. So we can put those two things together and accelerate that design cycle and close the gap between the concept and the production program. Because existing approaches to sound design and active sound design are very labor intensive and take a long time to take that, maybe a music studio type concept, and turn that into a realization in production. So I think simulation can really accelerate that process, and tighter collaborations between tool vendors, I think, can make that process much better and much more effective for OEMs and their suppliers. So I think it's a great question.
Yeah, I really like the idea of various industries and partners collaborating and using these tools as part of that collaboration. I think that's very powerful. Does anyone else have anything to add or any comments to this? Okay. Okay. Well, thank you very much. Certainly appreciate your comments. I want to then move on to Ashley. When I think about sound design and the NVH simulator, I think about the desire for a faster development process. That's something that we talk a lot about. One of your primary responsibilities is the development of driving simulation models for future product development. When using NVH driving simulation, how successful have you been in speeding up that development process?
It's proved to be very powerful. If we can think about the context in which we're working in the automotive industry, we're going through a revolution. Propulsion technologies are moving away from combustion engine technology to electrified technology. And also, given that there's a global requirement to reduce emissions, we're also looking at ways of managing the technology to deliver both reduced emissions, but also an experience that's great for the customer. So that there's a number of enablers for that. Sound design is one of them, because that can help integrate the propulsion systems to create the customer experience from a sound quality perspective. But we also need to think about how the systems integrate to create the whole. So there are a number of examples of where we may wish to run a propulsion system, for example, a combustion engine, for example, to charge a battery, which may produce noise and vibration responses which might be unfamiliar to a customer. So we can use a simulator to investigate those scenarios, because it enables us to integrate the propulsion systems with the data that we have around those and the models that we have to define those, and the control system on the vehicle. and figure out how we can get the systems to work together to minimize the impact of the customer and maximize the customer experience. And that's something that we've used the driving simulator to do in product development on a fairly routine basis now.
Yeah, and I think that you mentioned electrification in that and how quickly things are changing. Do you feel that we would be able to go as fast as we are right now if we didn't have these simulation tools?
I think that the simulation tools are a key enabler to make the transformation. It's traditionally been a challenge to demonstrate the NVH impact or effect of systems running in different ways, and to be able to demonstrate that at a concept level is very powerful, and it helps align NVH requirements against other requirements that we need to deliver for the customer.
Yeah, and I think a lot of the panelists that we have on right now are involved with electrification, at least to some degree or other. So I think from that aspect, you all have the potential of benefiting from it. I'd like to hear from someone else, if we can, on this. Maybe your thoughts or examples of how you've been able to use the driving simulator to speed up your development, or to take a very active role and rapidly solve a problem that maybe you're finding from one of your suppliers or one of your manufacturing facilities. Anyone wish to add?
Yeah, this is Glenn. I could expand a little bit on that. That was a great discussion, Ashley. But just to expand a little bit more on the sound design side of it also. The value of the simulator and kind of the tools really to bring a much quicker and much more straightforward development of a sound in the sound design area is if tools that are hard to use and maybe take a little bit more effort to develop something, a complex model, that starts to take away from some of the creativity that's important in the area of sound design, right? So to really open it up to the whole creative experience of sound design and really explore the creative space, I think aligning some of these tools in a way that's pretty easy and straightforward for even somebody, you know, with less an engineering degree, maybe more of a musical background or more of a background in a creative space it's an important area to push into, as you know, developing sounds and developing new designs for sounds for EVs becomes, I mean, obviously much more important and kind of mainstream.
Yeah, and we're going to talk a little bit more about the creative aspect later on, because it's something that really interested me. I got my simulator almost 12 years ago, 11 years ago now, and that was one of the things that really got me excited about the simulator was being able to reverse engineer and how I was able to take it to customers in that and get their opinion through jury evaluation and things like that, and make up sounds to try to determine what was most desirable. So and also going back to the timing aspects of it, I guess one of the things is time is money. So the faster we can do things, the quicker or the more money we're going to be able to save doing it. But Glenn, I really like your analogy to the creative arts or the musician or that sort of thing. It's very similar, except for instead of music, we're making car sounds, right? Anyone else have anything that they can wish to add? Okay, great.
I can come back and if Please. I can add another brief point. Where we found some great value in the use of the driving simulator is to help empower engineers. Sometimes if you're responsible for an element within the vehicle, it can be difficult to relate to how what you're doing on a daily basis relates to the customer. So we've successfully used our simulator to demonstrate, for example, how a modification to a component or a design change can influence what the customer experiences through the visual experience of driving the simulator. And that's really powerful, and it empowers the engineers to work on their parts.
Yeah, very true, very true. Okay, thank you. I appreciate everyone's input on that question. I'm going to move on to Marco now. Ferrari is known to make cars that are fun to drive, let's face it. And this is something that you know a lot about, Marco. However, there's a lot of industry discussion about the future of autonomous drive as well. Can you speculate on how the customer's perception and expectations of the sound and vibration attributes will differ between these two ideologies, between that fun sports car with a lot of input back and forth between driver and vehicle, and that autonomous vehicle? And is this something that we can predict using sound simulation tools?
Well, it's an interesting question. It's definitely it's a speculation at the moment, but it's going to become more and more tangible in the next future if the forecast is going to be respected in terms of the amount of vehicles going to go really being autonomous rather than being driven. Clearly, we can imagine that the most entertaining thing we can do in an autonomous vehicle is, as I used to say a few years ago, is to sleep, and that's not exactly having fun. I mean, some time ago, somebody asked during a conference, what would you do if you had the chance to, to being driven around? And I said, I just want to sleep. I just had my baby and at the time, and that was the desire. And that's a bit of a stretchy metaphor maybe, but that's really the key point in the fun to drive element. Everything is working in a symphonic way to deliver, the thrill of the drive. And so all the inputs are tendentially, loud. Also nowadays are not as loud as they used to be due to the various regulations. And also to the increased quality that even the most extreme sports car have nowadays in respect to a few years ago. Definitely, the expectation from autonomous drive is the input minimization, and but where is going to be this? How much is that going to be stretched before the brand DNA is going to be lost? I mean, you can imagine how an autonomous Porsche or an autonomous Jaguar, before we're going to get to an autonomous Ferrari, the customer expectation is not going to be exactly the same as a Rolls Royce or Bentley or any other brand. And so the challenge is going to be how to feed back that branding DNA from the sound and vibration character into these products without we still with a minimum focus on the undesired inputs. So definitely the simulator is going to be a key tool. We're gonna use that much earlier than anything physical to explore how sound and vibration connotation can be and branding can be preserved. We still going towards a higher level of refinement, and this is going to happen earlier for the perhaps for the ride characteristics, in order to to avoid motion sickness and other low frequency phenomena. Even before, for those beforehand, and then for what pure NVH is going to be, just for the principle that these systems have an impact on longer delivery time. It's going to be interesting. I mean, I'm not able to say now how an autonomous Ferrari is going to sound. Whether we're going to see it, well, in 20 years for sure. In 10 years, I don't know. But definitely, it's going to be a challenge. Yeah. And yeah, we will answer virtually before than physically for sure. And but on the other hand, I'll also look forward to see how much of the things we're going to explore virtually are going to be then really reflected on the first physical product that we're going to put into on its wheels, let's say, whether they will or wheels.
Yeah, I was going to say there's talk in the news and that lately of small personal manned flying vehicles. So perhaps Ferrari will be flying through the air instead of down the road. Okay, thank you. Can anyone else I find this to be a fascinating topic about autonomous vehicles and how we could use it, and just throwing in the sports car aspect to it is just a whole nother realm of customer perception. Does anyone else have anything that they'd like to add to this idea? Okay. So I'm going to move on to Rabah next. Rabah, much of my experience with the simulator is with the integration of test data to develop a simulator model. I'm interested in your thoughts about the integration of data from CAE tools into the simulator. How easy is this to do, and really, what are the potentials?
Oh, thank you, Colin. This is a great question. Also great to be here with the impressive panel. It's a very important topic, and it's true that the very first model we built with an NVH simulator are based on test data. But I would say this is actually just the first use. I think the potential and of the return actually of the investment in the tool is actually much higher when using CAE data, because then we can be predictive, and we can then analyze virtual prototypes. Now the process is actually by itself it is I would say relatively simple, because any sound can be either represented by a level you get at the driver's ear, or decomposed into source and contributions. And CAE simulation is being used for that actually, and has been used for a long time. I would say also that the access to CAE keeps increasing for people who have been using CAE. And we have to recognize that the cost of CAE is constantly decreasing. The cost of the software itself is decreasing, but also the cost of the resources. I mean, potentially what you need PhDs 20 or 30 years ago. Actually, now you can do it actually with people having less qualification, because it becomes standard tool. And so CAE is also widely available in universities. So then it's really expanding. And so there is a lot of information that has to be used into the NVH simulator, and to be predictive, to take it to the next level. One of the challenge in using CAE is always the accuracy. So in many of the projects we've done, we've been using CAE data, and always one of the first challenges is how accurate the CAE model is. But that should not be a showstopper. We also don't need an absolute correlation. We don't need to be line on line, because that also represents a cost. What we actually need to do, and that's where the difficulty is how can we make the best use of a CAE? So, and what I mean with this is, how can we use a CAE that is becoming, that is actually mature? How can we use CAE processes that are well established, that provides reliable results, and take it to the next level? And so for this, we need to also think of what can we then complement with the test. So we should always have a balance between where to invest in CAE and where to use test data. One simple example could be a supplier, for example. If we develop component, they may be very qualified and may have very good model of their component, but they may not have transfer functions to propagate those. And so then in that case, then using test data to transfer the sources or the result at a component level to the driver's ears is one way forward. And I would say the ball is rolling. I think we've been presenting earlier today several examples, and they cover a wide range of application, whether it's road noise, powertrain noise, etc. Now, there are still some areas that can be difficult. I'm thinking, for example, of wind noise, where, I mean, CAE is being used, but can still be relatively expensive in terms of effort and conditions to cover. But I would say that the main challenge is mainly on defining the process, and for the data manipulation, I think there is constant improvement in doing this.
Yeah, you hit on a couple of things that that hit home to me as well. One of them being the availability of CAE tools at the university level. It's impossible for me to keep up with what we're even teaching our students at the undergraduate level, and the software that's available to them on our engineering servers, because the cost is just coming down so much. So that's fantastic news, though. And yeah, I share your concern about the accuracy of the results when implementing them or integrating them in with something like a driving simulator. This is a concern that I share, but I think as the CAE tools get better and the users get better and a better understanding of the results, that hopefully should go away. And also I share your concerns. I've had projects with air acoustic noise, and computationally is very, very expensive. At least at universities, we have ways where we can share resources on nets amongst different schools and that. So, but even there, it can take a long time to run some of these things. I'm sure there's other people, other panelists that are also using or integrating data from CAE tools, whether it be your own group or whether you're getting that from another group within your organization or even a supplier. Does anyone else have anything that they could maybe share about the integration of the CAE into simulation?
Yeah, I'll comment on that. This one's actually kind of, it's an amazing topic, right? When you think about the time that we're at now, right? And kind of the tools that we have for simulation. Rabah talked about the tools that we have for the CAE tools to supplement the simulator with some virtual data.
Mm-hmm.
It's pretty amazing that we can essentially experience a car before any parts of it exist, right? There's zero hardware. We can bring it into the simulator and actually experience what we believe and what our best understanding of what that car will be. It's pretty amazing. And then as you start to go through and develop those models and refine them as hardware comes into play, right? They ideally, and of course, become much more refined and more representative. But it's and especially with this big wave of EVs coming out, right? This time now, prior to now, when it was more IC engine based, there's a big history there, right? A legacy of a huge market of IC engines. So the simulator space is pushed a little bit less because there's always some cars that are somewhat representative that you can work in hardware. But now in EVs, I mean, obviously in the last 10, 20, maybe even 30 years, there's been different versions of EVs out in the market, but it's a pretty limited offering. Now, right, we see the news. Every automaker has a massive wave of EVs coming out, and the market's going to just see an explosion of these. And the ability or the capability of the simulator to kind of develop those vehicles, I mean, virtually, when there are no great comparable vehicles that are out in the market. I mean, I'll talk just not to pitch GM, but the thought of the Hummer EV, right? There's just, you couldn't go and find a mule or develop a mule based on an existing vehicle. It just doesn't exist. It's a whole new product. So the idea that you can use simulation to develop these conceptual vehicles, and I'm sure it's in all the other automakers is the same thing. It's pretty amazing.
Yeah, I'm glad you brought up the point of electrification, electric vehicles, because seeing the type of research that my colleagues are doing at the university in their labs and their graduate students on the electrification aspects, I see so much of it being done using CAE tools, whether it be they don't have the resources or they just want to put the efforts into the prediction using CAE before they invest all that extra resources into building prototypes and doing the physical. And this is research that's not just within our own bubble. This is research that's in partnership with industry, with the OEMs and their suppliers. So that's a really good point that you brought up. How about anyone else? Can anyone else share experience with CAE integration into the simulator?
Yes, I can add to that.
Please, Ashley.
So I think it's I think Glenn made a really good point on being able to drive vehicles before they exist in hardware. That's one of the most exciting things about what we do. and the fact that we can be creative as well with what we've developed in simulation. I think we're at the stage now where we are getting more and more capability, and we're able to accurately or appropriately calculate responses to feed into the simulator. However, I think all our simulations, if we are to provide a full bandwidth and perhaps a driving experience, then we do need to integrate CAE and test data. So I think what's a really powerful enabler in the mantra or the envelope of the simulator technology as a whole is being able to build scalable models. So for example, to have a model which has test data to provide a context, but then you might incorporate into that a more complex CAE model to represent a specific component, and then you can demonstrate that component performance in the context. So having a full scale of integration of data, I think, is really powerful.
Yeah, obviously an interesting topic, and something that I think most of us would like to get more involved with, or see the potential of getting more involved with. I'm going to move from there. I'm going to move to Aaron for now. The idea of hardware in the loop or software in the loop, I find interesting. For those that aren't aware of this, this is where a system, whether it be a hardware component or a control system, is brought into the simulator environment to investigate and better understand what the integration of the system would be in the driving environment. I would think that there'd be many applications for this as a design tool, but especially for electric vehicles, given the number of control systems and how these controls are really having a larger part of the driving of the vehicle and the control of the vehicle. Aaron, as someone who is deeply entrenched in the electric vehicle world, what applications do you see for this type of technology?
Yeah, thanks, Colin. It's a really interesting question. Thanks for saving the most difficult one for me.
You're a Windsor graduate, so I know you can handle it.
Yeah, that's right. Exactly. I was taught well. I think in terms of hardware or software in the loop, right, there's a lot of applications that could be had, and especially as we think about expanding a bespoke or a specific NVH driving simulator more to the entire driving experience, around including vehicle dynamics, primary ride, secondary ride kind of things. We can then incorporate other maybe hill technologies like steering systems. And if it's done in a way that incorporates it directly into the simulator, then we can get some actual knowledge of what the hardware is doing without necessarily having a very well correlated model to rely on. Oftentimes, maybe something's carryover, and we could use that as a stand-in for having a model. Software in the loop is another interesting one, as EVs use a lot of software, right? I don't know what the last count is, tens and hundreds of millions of lines of code, right? Yeah. And incorporating maybe plant models in a Simulink way, or a DSpace box or something, to help to add more context around that driver experience. So maybe it's a matter of coordinating vibration from a model when you steer with actually how the steering is controlled, so that it's representative of what you might feel in the vehicle, and it adds that context around, so you're not completely disconnected and you're trying to have to imagine what it might feel like in a vehicle. You're actually feeling what it is in the actual vehicle.
Yeah, and to me, this is really adding a whole nother dimension to driving simulation. It's really starting to tie things together. Because this is something that may be a little bit new or foreign to some of the people listening. Rabah, do you have anything that you want to add to this subject?
I would say that similarly, actually, to the previous one, I think being able to use a simulator and evaluate the impact is a key. When dealing with vehicle developments, I think we're also dealing with different timelines, and some of the components are developed at a different time. And so if we can integrate them in a simulator, so then we can actually then make take the best profit of this decoupling. And the other key is also that, and I think it's a trend that has been started for already many years, is that some of the development effort actually is switching from the hardware to the software, and the software becomes actually takes I mean, that's a trend that continues more and more importance, and then being able also to factor that actually into a simulator is a key. We were talking about autonomous driving. Actually, that's going to push the trend even further. And so then being able to integrate all these components and then get an environment where we can actually test prototypes, but even before building prototypes, so do a simulation of a test is key.
Yeah, and talking about autonomous driving, think of the sensors, the sensor feedback, and integrating those and the response that we can get from that. That would certainly play a very large role in the autonomous driving as well. That's great. Thank you, Rabah. Thank you very much, Aaron. Appreciate your thoughts on that. I want to go to Glenn. When I think back in the history of car design, I picture the artistic approach that designers took in molding the shape of a future car using clay. They were indeed artists. Some may argue that a bit of that creative process has been lost. When we talk about sound design through simulation, we often think about it as a tool to help meet specific noise target levels. But these tools can go much further than that. As sound quality engineers, I think we both see NVH simulation tools as enablers of the creative process. And this already came up in our conversation today. Can you expand upon this idea and perhaps share how you see present and future simulation tools being used for this creative application of sound design?
Yeah, absolutely. And so sorry for jumping into the, I didn't know the question was coming.
No, you can just say what you said before.
Okay, repeat that. But no, it's a great question, because I think a lot of the discussion here, right, is about the simulator focused around an engineering tool. Obviously a huge value there, right? Being able to pull some of these virtual representations and doing the real hardcore engineering of setting targets, allocating those targets down to components and developing to them, right? But yeah, the whole separate or different path on that is that enabling a creative space, right? As sound design, and really the electric vehicles, they completely change the landscape or the canvas that you have to work with. An IC engine is in some ways bound by the powertrain that you have in the car. It contributes so much to the sound that you're somewhat constrained. EVs open that space. So taking the tools that enable us to connect with that creative world, right? Connect with essentially the sound designers in the same way that you mentioned clay, right? The interesting thing about clay is it's something that somebody with very little or actually no engineering experience can go and develop something in clay, right? They're working with their hands. It's just a natural way to, if you want to say, express themselves. And I think the direction that, well, and I'll say VI Grade is going with the connection with QNX and Blackberry, right? With the LiveAmp software, it starts to open that space. It gives some of the creative minds, and maybe with a limited experience of the simulator and maybe limited experience of CAE tools, but really a huge amount of experience in sound design and creative design. It gives them that outlet to be able to bring that creativity in and create the sounds, but still in the context of that vehicle, right? If you were to go and create sounds in a studio, you can come up with some, obviously amazing sounds. It's the whole music industry, right? Some of those may, but most of them probably don't translate directly into kind of the vehicle environment and the driving experience. So using a simulator and using LiveAmp to bridge that gap from the entirely creative musical space or whoever it is that's creating those sounds into the vehicle environment and then being able to experience them, it's a big bridge to build. And I think we'll see as these tools get more and more developed and if you want to say streamlined and sometimes even easier to use in some of those areas, I think we'll see some pretty cool things happening.
Yeah, and you brought up a really good point. One of the things I always say to my students when teaching them NVH, a lot of people think that NVH engineers, our job is to get rid of the sounds and make it go away, but that's not always true. And electric vehicles come to mind. Sound also provides us with feedback. It provides feedback that something is working properly or it's doing what it's supposed to be doing. And when we transition to electric vehicles, a lot of those things that we're used to aren't there. So our job might be to sometimes design back in some of those feedback components that sound gave us that the electric vehicles won't. So yeah, thanks very much for that. I'm going to go to Chris. When we talk about simulation tools, I think one of the fundamental motivators is to decrease development time, decrease test time, and decrease the use of hardware or prototypes. To use sound simulation tools as the primary vehicle development approach, this of course requires a buy-in from all those at the various subsystem levels. Chris, you are an NVH powertrain guy, and when I read what you're working on, I see it's very focused. Do you think the industry is capable of a holistic approach to sound design through virtual tools? In other words, can all subsystem partners come on board with each other?
Yeah, so as you were asking the question, I went back to the discussion about the CAE tools and how we can integrate those, right? Because I think it's directly related to this question. And yeah, I wanted to chime in on that discussion as well. And Ashley had some of the same thoughts that were going through my head at the time. You know, the CAE, we have various methods with different levels of maturity. And you know, to do a sound simulation, we need a rich spectrum of sound. And even our most mature CAE methods at the subsystem level don't necessarily give us that full spectrum of sound. And we've integrated the CAE with a lot of our test data and taken a hybrid approach. And even with those CAE methods that are not fully mature, you know, we've taken the approach of using the simulations and the deltas in CAE models and applying those same deltas to our measurement data to give us an indication of what we can expect. And so we're doing that with the various subsystems. And you know, I think we've had a lot of success in doing so. I'm thinking the exhaust system in particular, we've done a lot at the subsystem level and are bringing those tailpipe level measurements into our simulator models and making decisions very early on about, you know, the content we need. So as I mentioned, we're using CAE when we can. We're using dyno rig data when we can. Obviously, the vehicle prototypes, it's an industry trend to reduce or eliminate those. So we're having to rely on the CAE, having to rely on rig-based testing and bringing those all together to conduct these simulations. And yeah, we've had a lot of success. So I definitely think it is possible to you know, develop powertrain NVH using the subsystem-based approach and bringing everything together, making decisions, making sure we have the right content at the lowest cost to satisfy NVH requirements for the full vehicle.
Yeah, and I think one of the comments made earlier about Rabah, I think, said how a lot of these tools not only are becoming more available, but easier to use. And I think as they become easier to use, and so will the integration between the various users and they'll just start to mesh together. Yeah. Anyone else have anything to add on this thought? Okay, I'm going to, everyone's been great on this. As they say, though, I'm going to leave the best to last, and I'm going to move to Dave. Dave, we've heard a lot of great and promising things today about how NVH simulation tools are allowing VI grade customers to innovate the design process and to not only improve NVH and troubleshoot issues, but also increase the pace of the development process. And that's key, because that's how profits are increased. I'd like to hear from you about what we can expect to see from VI grade in the future. What innovations do you have in the pipeline for your customers and your partners?
Yeah, sure. And just to recap or touch on what you just said, it is really impressive and amazing how, you know, the breadth of application of the NVH simulator technology is in the different areas that we've discussed today. But, you know, moving into the future, one of the things that was announced yesterday is making it easier to use vibration as an assessment, something that people can actually experience and feel with the compact simulator. That's a focus right now, to make that more accessible. You know, because I think that vibration is a really key important of the overall NVH experience, right? It's the V part. So
it contributes to the context.
Yeah. You know, in addition to everything we've talked about today, we look at you know, NVH as being part of the overall holistic experience of the vehicle, and we're incorporating hardware in the loop and software in the loop more and more. And I think that really the next step there is to start integrating other attributes as well, and evaluating NVH together with vehicle dynamics, or together with the autonomous characteristics of the vehicle, or together with other aspects of the vehicle. And that's something that we're really excited about doing, is bringing these different attributes together, so we get an even more holistic experience, a more holistic environment to evaluate these virtual prototypes in. So we want to keep making it easier and easier to use these tools, as many mentioned here. You know, we want to make this so it's you know, easier to use the tools. You know, you could call it democratizing the NVH design, or you know, going back to that clay model analogy, you know, anybody can walk up and start working with the clay. We definitely want to head more and more in that direction of making it easier to realize the vision that we're of the vehicle.
Yeah, I want to bring up that one of the words that's come up, or phrases that's come up several times today, is holistic. And I think if you look back in history of CAE tools and simulation tools, as the technology was being developed, it was still somewhat independent. You know, you had a tool for this and you had a tool for that, etc. But now, through the efforts of companies like VI Grade, we see them all coming together. We see that holistic ideology coming to fruition, where we're able to tie in these different areas into one big common thing. And the hardware in the loop is a really good example of that, or the software in the loop. And it's something that I don't know a lot about, and I'm interested in learning more. So yeah, it sounds like there's a lot of great things are coming our way in the future. It looks like we are out of time. I think we're in our last minute. So I really want to extend my thanks to all of the panelists for your contribution today. I think you gave us a lot of insight with what you're able to share with what you're doing, and things that we're going to see in the future. But also, I want to recognize everyone, our audience out there too. Really appreciate you joining us. Obviously, it's showing that there's an interest in this, and it's a field that's going to continue to be needed and continue to grow. So thank you very much, and enjoy the rest of the conference.